Okay, so I have graded the Proctored exam, and the grades are posted. So if you have questions about your grades, call me or send me an email. I'll be glad to look at them and see. Sometimes I do make mistakes, so do not hesitate to send me an email, and I'll be glad to look at your tests again. I still have them, and I will mail them to you sometimes this week. So if you have any questions, send them to me very soon. Okay, this week we have an interesting chapter on rational functions. So let me first of all define what rational functions are. A rational function, which let's use the term R to represent rational function, is the division of two polynomials. So let's say if we take P of x over Q of x. So P of x over Q of x, in this case, we're assuming that P of x is a polynomial and Q of x is also a polynomial. So that's how we define rational functions. So let's look at an example. A very simple example would be, let's say R of x is equal to x divided by 2x plus 1. The top is a polynomial and the bottom is a polynomial. So this is an example of a rational function. So now let's look at something a little bit more difficult, where we have to find the domain of a rational function. This is where it gets a little bit more complicated, because we'll look at, let's say for example, we'll look at x squared. So we'll look at a function like R of x is equal to x squared minus 4 divided by 3x squared plus 9, 9x. Okay, so we have a rational function here. The way it looks, well, let's test. The top is a polynomial, this is another polynomial, so we're in good shape, right? In fact, the top is a polynomial of degree 2, right? And the bottom is a polynomial, the denominator is a polynomial of degree 2 as well, right? This is a rational function. So the first thing we're going to look at about this rational function is, how do we find the domain of this rational function? Well, I mean, the best thing to do here, remember what we are not allowed to do. We are not allowed to divide by 0. So anything that will cause us to divide by 0 will exclude those points, right? So how do we know what will cause us to divide by 0? So let's look at the top. The top is x squared minus 4, right? We can factor this into, right, x plus 2. I'm sorry, I have a 2 here. X plus 2, this is the difference of 2 squared, over x minus 2. I'm sorry, times x minus 2. Divide by 3x squared plus 9x. So here we can factor out a 3x, right? You look at those two terms, we have 3x in common. So we have 3x, right? X, we okay with that? So 3x times x is x squared plus, okay, 3. Okay, let's write this as a division. Now, if we need to find the domain of this, I know you can't see this here. So if we need to find the domain here, we have to look at what will cause the denominator to be equal to 0, right? So the first thing we're going to do is say, okay, remember, if 3x is 0, the whole thing is 0. If x plus 3 is 0, the whole thing at the bottom is 0. Remember, multiplication by 0 will give you a 0. So here if we set 3x to be 0, remember these are the point we're going to exclude. X is equal to 0, divide through by 3 here, so we have x is 0. So x cannot be 0. Notice that we are saying x cannot be 0. And for this one, we're going to have x plus 3 is 0. X is equal to negative 3. Now, those two values will cause us to divide by 0. So we cannot have x is equal to 0 and x is equal to negative 3. So we cannot have those. So everything else is okay. Can the top be 0? Can the top be 0? Can x be negative 2? Yes, the top can be 0. But the bottom cannot be 0. So we have to be careful with that. We cannot divide by 0. But 0 can be divided by something. Okay, so the domain here is actually all real numbers except for 0 and negative 3. Okay, so remember, it can be anything here except for all reals except for 0 and negative 3. Okay, so let me look at another one. So let me look at something a little bit harder. For example, I'm looking at, well, let me pick number 25 in your book. So we're looking at page, what page is that? 419, number 25. Number 25 says 3x minus 2 divide by x minus 1 to the squared. Okay, so the question is find the domain of the rational function. Well, this one is not too hard because the only value that will cause me to divide by 0 here, I need to exclude, is when x is equal to positive 1. Right? When x is equal to positive 1. If I put in positive 1 for x, so I have positive 1 minus 1 is 0. 0 to the squared. Right? 1 here. 1 minus 1 is 0 to the squared will give me a 0. So I cannot have x cannot equal to 0. I'm sorry, x cannot equal to positive 1. Okay? So you know how to write this. I did not write it in the previous example. So it's all real except for x cannot be equal to positive 1. So one way to do this is negative infinity to positive 1 exclusion. That means open interval. So we're not including the 1. And then 1, we're going to union that, 1 to positive infinity. Right? So all these numbers. Right? So this will make sure that you exclude the 1. Remember, this means the open interval, and the square bracket means the closed interval, that you include the endpoint for the closed bracket. Okay? So, quick one, another one, number 26, I think, in your book. Number 26. Okay, just an explanation on this one. X plus 5 divide by x squared plus 8x plus 16. Okay, again here, what we're going to try to do, we're going to try to factor this out, right? So we have the top is x plus 5, right? The bottom is, it's always easier to work in factored form. So x, 2 factors of 16, that will add up to an 8. So x plus 4, right? We okay with that? X plus 4. Right, let's double check. X squared, yes. 4x plus 4x gives me 8x. 4 times 4 is 16. So what's the domain here? The domain is all reals except for minus 4, because minus 4 here, x cannot equal to minus 4, because if I let x be negative 4, that will cause me to divide by 0. And I do not want to, I'm not allowed to divide by 0. Okay? Okay, let's continue with another question here. So number 32, again still on page 419, number 32. Okay, number 32 is 6x minus, let me make sure here, number 32 minus 42 divided by x cubed minus 7x squared. So that's number 32 on page 419. So again, here we need to simplify, and we'll talk about the domain as well as we do this. So this is equal to, let's factor the top. So we factor a 6, okay, x minus 7, right? 6 times 7 is 42. Negative 6 times 6 times negative 7 is negative 42 is what we want. Here, the common factor, the largest common factor out of these two is x squared. So we factor out an x squared. We are left with x minus 7, right? So in this case, these terms will cancel. Cancel means divide out to give you a 1. So we have 6 times 1 is 6. X squared times 1 is x squared. So that's the simplified form of this rational function. Okay? Now you have to be careful. If we look at the domain, we have to look at this, not this. Okay? We have to look at this, because in this one, x cannot equal to 7 and x cannot equal to 0. So we have to, when we look at the domain, we have to look at the original expression, rational expression. Okay? I'm going to look at another one, but I'm not going to do it on this recording. So I'm going to wait a second here and then start another one and look at it on the second recording, because I think there may be a limit here, but I could try and see. Well, let me do another one just to be on the safe side. So I'm going to stop this one, save it, and